Comparison between SN1 and SN2 reaction. We will correlate both these reactions with respect to different factors, and we will check out how these factors influence one or another reaction. But before addressing these factors, let's first focus briefly on each of these mechanisms. Let's first focus on SN1. S stands for substitution, N stands for nucleophilic, and 1 stands for unimolecular. Consider a reaction tertiary butyl bromide, which reaction in the presence of solvent water we get tertiary butyl alcohol. This sort of SN1 reaction in which water has used as solvent. It is two-step mechanism. Step 1 involves slow ionization of substrate. This is reversible for generating a carbocation, and the second step involves a nucleophilic attack by the water on carbocation, and one more step which is deprotonation of the water or hydroxyl group. Hydrogen is lost and we get a tertiary butyl alcohol. So this is a simple SN1 mechanism that proceeds through 3 different steps. The first step is slow, and it is rate determining step. As the rate determining step involves just one molecule of the substrate, that's why it is unimolecular, or in other words the kinetics in which the rate is equal to K1 substrate. Only the concentration of substrate determines the rate of a chemical reactions. That's why SN1 is unimolecular. As far as SN2 mechanism is concerned, so it is substitution nucleophilic bimolecular. Here the 2 stand for bimolecular substitution. Nucleophilic bimolecular reaction. It is a single step mechanism in which a nucleophile take a substrate for expelling the leaving group, and we get the product. So this is SN2 reaction, which is single step mechanism. That's why we call it concerted, because both the attack of a nucleophile on the substrate and expulsion of the leaving group chloride take place in the single step. So that's why it is concerted or a single step mechanism. As far as the kinetic is concerned, the rate is equal to the concentration of substrate and nucleophile. That's why we call it bimolecular in character. Hence SN2 is bimolecular. So let's now focus on different factors that relates both SN1 and SN2 reaction factors. Influencing SN1 and SN2 reaction. So the first factor is a nucleophile. Usually SN2 require strong nucleophile because it is involved in the rate determining step. This is a single step, so this is a rate determining step. As far as SN1 is concerned, so there is no involvement of nucleophile in the first step, which is rate determining step. So therefore in SN1 no need of strong nucleophile. Second factor is about solvent. Usually SN1 required good ionizing solvent because it is needed in the first step for ionizing the substrate into a carbocation. But as far as SN2 is concerned, there is no need for such requirement. Usually polar protect solvent is required in polar protect solvent is required, such as methanol or acetic acid. These are polar protect solvent or ammonia, which are needed for facilitating SN1 reaction. But as far as SN2 reaction is concerned, it requires a good nucleophile rather than a good solvent. The third factor is substrate. Usually in SN1 we observe that a carbocation is formed, so usually more substituted carbocation or tertiary carbocation is highly stable. So therefore if the starting substrate is substituted or bulky, and then we can say that it will facilitate SN1 reaction. That's why the rate of SN1 reaction is faster in tertiary alkyl halide than secondary, which is in turn faster than. Usually in tertiary alkyl halide SN1 reaction takes place. And as far as SN2 reaction is concerned, which involve a backside attack by the nucleophile on the substrate for expelling the leaving group, therefore it order of reactivity is reverse with respect to SN1 reaction. Usually SN2 reaction takes place faster in primary than secondary, and there is no SN2 reaction at tertiary substrate. So the order is reverse with respect to both SN1 and SN2 reaction when we consider the substrate. Usually a bulky substrate is required in SN1 reaction, and a sterically less hindered substrate is required in SN2 reaction. Now let's move to the next factor, which is about rearrangement. In SN1 we observe a formation of carbocation that is prone to rearrangement. Therefore rearrangement takes place in SN1. But in SN2 no rearrangement. The stereochemistry, next factor is stereo. Chemistry. As in SN1, a planar carbocation is formed. Therefore, in the last step or in the second step, a nucleophile can approach from both above and below the plane. Therefore, we get a racemic mixture. And as far as SN2 is concerned, there is inversion of configuration. So let's summarize all these factors. Nucleophile, usually a strong nucleophile is required for SN2 reaction, and no need of such strong nucleophile is required for SN1 reaction. As far as solvent is concerned, a good polar protic solvent is required, such as ethanol or water, for ionizing the substrate. But as far as SN2 reaction is concerned, it requires a good nucleophile rather than a good solvent. Substrate, usually a bulky substrate or tertiary alkyl halide facilitate SN1, and primary alkyl halide facilitate SN2 reaction. In SN1, rearrangement take place, where in SN2, which is single step mechanism, there is no rearrangement. Stereochemistry, SN1 give racemization or racemic mixture, and as far as SN2 is concerned, it give inversion of configuration. For example, if we have a starting material of R configuration in SN2 reaction, then in the product we will get the isomer of S configuration. As far as kinetic is concerned, so in SN1 the mechanism is unimolecular, or the rate is dependent on the concentration of substrate alone. And as far as the kinetic of SN2 is concerned, it is bimolecular in character, which depend upon the concentration of both substrate and base. SN1 proceeds through 3 different steps, step 1, 2 and 3, where SN2 mechanism proceeds through just a single step mechanism. That's why we call it concerted mechanism, in which the nucleophile approach from the back side to the leaving group. Thank you for watching the video.